Can someone smart explain to me how time slows down for someone traveling at light speed? Consider how Einstein explained where he got the idea. You're on a bus, driving down the street away from the clock tower at the center of town. You see it says that it is 11 a.m. But the only reason you can see what time it is because the light from the clock is reaching you. So if your bus was going light speed, then the time on the clock would never change because the light from it would never reach you. Therefore, as you go faster, it takes longer and longer for the light to reach you. It is taking longer and longer for time to pass for you than it is for anyone outside of your bus. But because light moves so fast, you would need incredible speeds to achieve this. Speed equals distance as time. If the speed of light is constant no matter what, at least one of the other two things must be flexible in order for differently moving observers to measure light traveling at the same speed. There is an equation which I can't remember. It's fairly simple, but not that simple. But if you graph speed on a graph on the x-axis and the perception of time on the y-axis, the result of the equation is always equal. So, as the speed gets faster further right on the graph, the experience of time approaches zero. When speed reaches the speed of light, the experience of time is none or zero. And this is one reason why can't go faster, because the experience of time stops at zero, it can't go negative. Light travel at a constant speed in a medium vacuum. So if you were traveling really fast, light would need to travel faster to seem it travels at the same speed, but it can't. So that it travels at the same speed, time needs to flow slower. Please note that it's a really home-cooked explanation, and most likely not the real cause, but it's easy to understand it like this for me. And I am no physicist. I like to first imagine that photons, or anything traveling at the speed of light, does not experience any time passing. Time is essentially frozen for anything traveling at light speed. As an object or anything with mass decreases speed slower and slower, your time will speed up relative to objects traveling faster. The fun example I read somewhere, can't remember which book, is the identical twin paradox. You take one twin, put him on a spaceship that can travel 99 speed of light. At that speed your time slows by a factor of 7x. So one twin flies out at 99 speed of light for 6 months, turns around and comes back to Earth. The spaceship twin has experienced 1 year of time passage, while his twin on Earth has experienced 7 years due to the time dilation. Your identical twins are now aged 6 years apart, 7-1 due to time dilation. Crazy stuff. Imagine two trains going towards each other at 100 miles per hour. If you are on one, and it is not accelerating, it feels like you are not moving. Your velocity relative to the train is zero, because you are both moving the same speed and direction. This means it will appear that the other train is coming towards you at 200 mph. When you scale this up, it becomes really problematic when a train's hit half the speed of light. Your relative velocity to your train is always zero, but now it will appear that the other train is going faster than the speed of light, which is not possible. Nothing can move faster than light. This is the basis on why time dilation is perceived. So when moving at light speed, no other light from anything else can catch you. It's almost like you're playing tag with other photons, but you're moving so fast that other photons cannot get to you. So if you were to be moving at the speed of light, no other photons would be able to alter your perception of the world around you. You're mistaken on degree. Anything traveling at the speed of light does not experience time at all. Because space and time is connected, imagine time as some sort of elastic rope that everyone is holding into. When moving slowly, the rope stays relaxed, pulling harder on that rope. The faster you go, the more stretched the rope gets. Now, for anything moving at the speed of light, the rope is stretched to its limit. It doesn't move anymore, so time stops entirely. This is because time and space are connected in a fabric called spacetime. When you move faster, more of your effort goes into moving through space, leaving less for moving through time. So time slows down for you. Because you're going relatively fast, you are constantly traveling through both space and time. Nature has set a speed limit on how fast you can go through either. Let's call travel through space x and travel through time y. X and y can vary, but they always have to add up to z. xy equals z. Speed through space plus speed through time equals your overall speed through life. If x speed through space increases, then y speed through time has to decrease to still equal z. If x gets really big, so big that it's almost equal to z, y has to get really small. So if you move through space really fast, you have to move through time really slow. Nature's speed limit z won't let you go fast through both at the same time. Imagine you're dribbling a basketball. It goes down 3 feet straight down to the floor, then straight back up 3 more feet to your hand, traveling 6 feet in 1 second. Now imagine you're doing that on a moving train. I watch the train go by at say, 8 feet per second. When you dribble, I watch the ball travel the hypotenuse of a triangle down and forward, then another back up and forward. Some quick math tells us that, from my perspective, the ball moved 10 feet in that same second. So how far did the ball move? 6 feet or 10? Both, because that's how relative motion works. Time dilation works in a similar way. When you start moving at relativistic speeds, time becomes the basketball, following the same path, but that path looking different to different observers with different viewpoints. It depends on your definition of time. For me, time is a philosophical thing, so to me, time doesn't slow down, processes do. Here's a video that made me understand what's going on. https://u2.bvf8yv x8c psi equals UGP80DCDA FCQ XLP. Simple answer. Space and time are inextricably linked and referred to as spacetime. You are moving through spacetime at the speed of light no matter what. The faster you are moving through space, the less you can move through time. The slower you go, the faster time has to pass to ensure you're moving through spacetime at the speed of light. Of course, it's not quite that simple. That would just be how an outside observer in another reference frame would see things. To get a better understanding, it helped to learn about relativity and reference frames. But I'm far from qualified to break all that down properly. I just watch PBS Spacetime to pretend I'm smart. Because you move through time faster. https://u2.bvf8yv8c. This video was quite insightful for me. Understanding why matter other than light cannot reach the speed of light is useful for understanding why light experiences no time dilation, since photons have no concept of time. You go 90 the speed of light. Time feels normal for you. You watch the universe through your window. The universe is going faster for some reason. You stop your ship, you have traveled for 1 day. For the rest of the universe, it's been 55 hours, more than 2 days. The closer you are to the speed of light, the more time slows for you. At full speed, time completely stops for you, while the rest of the universe would age millions of years. Space and time are a single object called spacetime. It is like a brick with 4 dimensions. Causal relations propagate through the block at the speed of light. You and I are moving at the speed of light through spacetime right now. An object's speed in a direction of space detracts from its speed in the direction of time. That object then perceives that change in time as a contraction of objects in the direction of travel. If an object were to be accelerated to the speed of light, from its perspective it would reach the edge of the universe at the end of time, instantly. That's why photons never seem to decay. They don't experience time because they are traveling at the speed of light. Another explanation, the speed of light is the same for everyone. If you get in a rocket traveling half the speed of light and shine a flashlight in front of you, you will see the light traveling away at the speed of light. However, me on the ground will not see the light beam traveling at 1.5 c. It will just be the regular speed of light. So that means that we must disagree about how long it takes the beam of light to arrive on its target. This is called time dilation. Time is relative to the observer. And the faster you go, the slower time moves for you. So let's say you have 2 people. Person A is stationary on Earth and will be monitoring a spacecraft's journey. Person B will be traveling 11 light years away at, let's say, 80 the speed of light. Person on Earth will watch the craft travel 11 light years away, which will take around 13.75 years at 80 speed from their perspective. Person B will experience around 8.25 years of travel time inside the craft moving at 80 speed of light from their perspective. This can be calculated with a simple formula. T equals TSQ, or T1 VCT is the total time that will be experienced by the traveler, person B. T is the time that will be experienced by the stationary observer, person A. V is the speed of person B. C is the speed of light. TLDR, time itself slows down from your perspective if you move really fast. You only experience time because your brain is an organic machine that continuously generates and responds to signals from various sources, including itself. This activity happens at the speed of light, and at large enough volume that your brain hallucinates you into existence. Light itself doesn't experience time. There is no clock associated with any photons, they merely exist and move and become absorbed as energy or manifest from energy. A photon passing through the lens of your eyeball could be made from the same energy that left the farthest star you could see with a telescope from billions of years ago, and that photon experienced 0 time. Photons experience no time because they travel so fast. If you accelerate closer to the speed of light, your ability to experience time gets closer to that of light itself, which is none. If you could travel at the speed of light, your experience of time would stop entirely, because you were traveling at that speed, but it would take an infinite amount of energy to accelerate to that speed. This is why it is called relativistic speed, because it is some relative factor close to light, but it can never actually get there. A being with mass cannot travel at the speed of light.